So, let's go. While the entire world was watching 4 astronauts loop around the moon, Mars was quietly rewriting everything we thought we knew about it. An ocean the size of the Arctic. Lightning in a world we assumed was dead. Organic molecules that no one can explain without invoking life. And a planet that's literally spinning faster than it was last year. These are 9 discoveries that deserved front-page headlines. But you probably missed every single one of them. Because while Artemis dominated every feed and every algorithm, the robots we left on Mars were uncovering a version of that planet that is stranger, more alive, and more unsettling than anything we imagined. So let's fix that. Number 1. Mars once had an ocean larger than you think. You already know Mars used to have water, that's old news, but what's not old news is the scale, because recent mapping of ancient river deltas, particularly inside Valles Marineris, which by the way is a canyon system that stretches over 4,000 kilometers and drops 7 kilometers deep, revealed something that changes the picture entirely. Scientists identified over 6,500 kilometers of ancient river channels organized into 20 separate delta systems, and all of them drained toward the same place: the northern lowlands. Now here's the thing about river deltas. They only form when a river dumps sediment into a large standing body of water, an ocean, a sea, something massive enough to shape how the sediment fans out. And when the researchers checked the elevation of every single one of these deltas, they all sit along the same gravitational surface, the same ancient sea level, which means this wasn't a bunch of scattered lakes. This was one body of water. And based on the surface area and depth estimates, it was roughly the size of Earth's Arctic Ocean, maybe larger. We're talking about a volume of approximately 6 million cubic kilometers of water, covering nearly a third of the planet's northern hemisphere, half a kilometer deep in places, possibly deeper. 3.5 billion years ago, if you were standing on the Martian equator looking north, you would have seen a coastline. Waves driven by wind, not tides, because Mars has no significant moon to pull at the water. A yellow-orange sky hanging above a dark sea, a horizon where rusty land met water and just kept going. Over 15,000 kilometers of coastline wrapping around the northern hemisphere of a planet we now think of as a frozen wasteland. And here's the uncomfortable part. This ocean may have lasted for hundreds of millions of years. That's not a puddle that formed and evaporated. That's a feature of the planet. Something stable enough that anything falling into it had a real shot at becoming something alive. But Mars didn't just have an ocean, it had the climate to match. Number 2, Mars had tropical rainfall for millions of years. Inside Jezero crater, Perseverance found something that stopped researchers cold. Bright white rocks scattered across the red landscape. And when the rover's instruments analyzed them, they turned out to be rich in kaolinite. That's a white clay mineral with a very specific formation requirement. On Earth, kaolinite only forms under one condition: prolonged extreme rainfall in warm, humid environments. We're talking tropical rainforest levels of water, more than a meter of rain per year, for millions of years straight. The process works like this. You start with feldspar, a common ignite mineral, then water, enormous amounts of it, slowly leaches away every other element. Iron, magnesium, potassium, sodium, all stripped out over millions of years until nothing is left but pure aluminum silicate, kaolinite. On Earth, you find thick deposits of it in the Congo Basin, Southeast Asia, the Amazon, places where rain hasn't stopped falling for geological ages, and now we're finding it on Mars, on a planet where it hasn't rained in over 3 billion years, sitting in plain sight on the floor of a crater. The kaolinite in Jezero isn't a trace. It's distributed across kilometers of ancient lake deposits, which means Mars didn't just have a wet afternoon 3 billion years ago, it had a sustained hydrological cycle, clouds forming, rain falling, rivers flowing into that northern ocean, and the whole process repeating for millions of years. Long enough to chemically transform the bedrock itself. Now you might be wondering, okay, so where did all that water actually go? Because we're talking about an ocean and a tropical climate, and somehow Mars ended up as a frozen desert. Turns out there's a culprit. And it's not what scientists originally thought. Number 3, regional dust storms are ripping the water off Mars. For a long time, the assumption was that only massive planet-wide dust storms could strip water from the Martian atmosphere, the kind that block out the sun for months. But a study published in 2025 flipped that idea. Researchers found that smaller, more intense regional storms, particularly during the northern hemisphere summer, are doing most of the damage. Here's how it works. A regional dust storm kicks up. The intense updrafts carry water vapor high into the atmosphere, 40 kilometers up or more, way above the altitude where it's normally confined. Once the water vapor reaches those heights, ultraviolet radiation from the sun tears it apart, breaks the water molecules into hydrogen and oxygen, and hydrogen, being the lightest element in the universe, doesn't stick around. It drifts upward until it hits escape velocity, about 5 kilometers per second, and just leaves. Gone. Into space. Forever. During one of these storms, the hydrogen escape rate triples, 3 times faster than normal. And this isn't a one-time event. These storms happen every Martian summer, year after year, century after century, for billions of years. Each storm peeling off a little more of what used to be an ocean, a little more of what used to be rain. The oxygen stays behind. Some of it bonds with iron on the surface. That's literally why Mars is red. You're looking at the rusted remains of an ocean. The entire planet is covered in what's left of its water. But if you were hoping that maybe, just maybe, some of that water survived underground, the next discovery is going to hurt a little. Number 4. The underground water we thought existed probably doesn't. Back in 2018, the Mars Express orbiter found something exciting under the South Polar ice cap. Bright radar reflections, about 3 to 4 kilometers beneath the surface. And on Earth, bright radar reflections at that depth usually mean one thing: liquid water. Scientists publish papers. Headlines ran. The idea of a hidden subglacial lake on Mars captured everyone's imagination. But newer, higher frequency radar scans told a different story. Researchers modeled what kinds of materials could produce those same bright reflections and found that smooth layers of compacted clay minerals, dry ice, and dense frozen ground can mimic the signal of liquid water almost perfectly. Especially at Martian temperatures, which at the South Pole hover around minus 120 degrees Celsius. Way too cold for liquid water, even with dissolved salts. And the distribution didn't help the water hypothesis either. Scientists found dozens of these bright spots scattered across the South Polar region. If every single one was a hidden lake, Mars would need an improbably high level of geothermal heating that no model supports. Clay minerals fit the data without requiring exotic explanations. So the liquid water that made so many headlines a few years ago most likely isn't there. Dry ice and clay are still interesting from a geological perspective, but they can't support life. They can't sustain a future colony, and they definitely don't carry the same weight as a hidden ocean waiting beneath the ice. Sometimes the update is that we were wrong, and this is one of those times. And speaking of losing things, let's talk about 2 pieces of bad news that happened while everyone was focused on Artemis. In December of 2025, NASA lost contact with the MAVEN orbiter. The spacecraft went silent after passing behind Mars and never came back. 4 months later, still nothing. MAVEN was the primary tool for studying Mars' atmosphere and served as a critical data relay for rovers on the surface. It was also the only orbiter capable of detecting plasma waves, which matters. For a discovery we'll get to in a moment, losing MAVEN is like losing your only pair of glasses on a planet you're still trying to read. And then there's the Mars Sample Return Mission. Cancelled. The plan to bring back 33 carefully sealed samples collected by Perseverance, samples that could definitively answer whether life ever existed on Mars, was killed by an $11 billion price tag that Congress refused to fund. Those samples are now sitting in sealed titanium tubes on the surface of Jezero crater, waiting. China is planning a grab-and-go sample return for around 2028, but their mission won't retrieve Perseverance's curated collection. It'll just scoop whatever rock happens to be near the landing site. The most carefully selected Mars samples in human history might just sit there in the dirt for decades, maybe longer. All right, let's move on to something that doesn't make you want to throw things. Number 5. Perseverance found a meteorite that could fuel a future Mars base. In September of 2025, Perseverance stumbled across a rock that looked completely wrong. Sitting among the flat, fragmented basalt of Jezero crater was an 80-centimeter wide chunk of metal. Bright, reflective, sculpted by atmospheric entry. It looked like someone had dropped an engine block in the middle of a Martian desert. The rover's supercam hit it with a laser, and the spectroscopy confirmed what the team suspected: iron and nickel. Classic asteroid core composition. This wasn't from Mars. This was a meteorite, a piece of a shattered asteroid that slammed into the planet who knows how many millions of years ago. NASA named it Fipsaxle after a site in Svalbard, Norway. Now, one meteorite isn't exactly a game changer by itself. Other rovers have found them before. But what's strange is that Perseverance went nearly 5 years without finding a single one, even though Jezero crater is the same age as regions where other missions found meteorites much sooner. Nobody's sure why it took so long. But here's where it gets interesting for the future. If humans ever establish a base on Mars, iron and nickel meteorites like this one become raw materials. You don't need to mine. You don't need to smelt ore. The metal is just sitting there on the surface, pre-refined by billions of years of space travel. Tools, structural supports, radiation shielding, all from rocks that fell from the sky. You wouldn't even need to bring metal from Earth. Mars has been collecting it for you for billions of years, free delivery, courtesy of the asteroid belt. The question now is whether we'll ever actually get there to use it. But regardless, knowing these resources exist changes the math on future colonization in a big way. Now that was a cool discovery, but the next one might be the most important finding on Mars in the last decade. Number 6. Scientists found molecules on Mars that they can't explain without life. In 2025, a team of researchers reanalyzed a sample that Curiosity drilled from a mudstone called Cumberland back in 2013. Using upgraded protocols on the SAM instrument, they detected something that hadn't shown up before: long-chain alkanes. Specifically, decane, undecane, and dodecane, chains of 10 to 12 carbon atoms. On Earth, these molecules are overwhelmingly produced by living organisms. They're fragments of fatty acids, the building blocks of cell membranes. When organisms die and decay over millions of years, their lipids break down into exactly these kinds of hydrocarbons. That's what petroleum is. That's what natural gas is. Millions of years of dead marine life compressed into chemistry. Now, the concentration is what really raised eyebrows. The team measured around 50 parts per billion of decane in the current sample, but Mars's surface has been bombarded by cosmic radiation for 3.5 billion years, radiation that destroys organic molecules. When they modeled how much radiation damage the sample should have sustained, they calculated the original concentration was somewhere between 120 and 7,700 parts per million. That's orders of magnitude higher than what any non-biological process can produce. They tested every alternative: meteorite collisions delivering organics, atmospheric chemistry, hydrothermal vent synthesis. None of them could generate that much alkane material. The only mechanism that reliably produces long-chain alkanes at those concentrations, on Earth anyway, is biology. This is not proof of life on Mars. The researchers were careful to say that. But as they put it, biological origin is a reasonable hypothesis. And right now, no one has a better one. Every non-biological recipe they tried came up short. The math just doesn't work without something organic producing these molecules in bulk. Something that was alive, something that died, and something that left its chemical fingerprint in a piece of mudstone 3.5 billion years later. Those samples, by the way, the ones that could confirm or deny this with lab equipment 1,000 times more sensitive than anything on Curiosity, those are the ones sitting in sealed titanium tubes on the floor of Jezero crater, going nowhere. If there was ever a moment where you feel the weight of the sample return cancellation, it's right here. We might have the answer to the biggest question in the history of science sitting in a tube on Mars, and we just decided we couldn't afford to go get it. But let's shift from ancient chemistry to something happening on Mars right now. Something nobody predicted. Number 7, Mars has lightning. For the first time ever, scientists confirmed the existence of lightning on Mars, and the evidence came from something called a whistler. That's a very low-frequency radio wave that lightning generates when it strikes. On Earth, if you tune a radio to the right frequency, you can actually hear them. A descending tone, like a whale call played in reverse. MAVEN detected one on June 21, 2015. A single whistler signal. A smooth frequency sweep from about 10 Hz down to half a Hz, lasting less than half a second, and it came from the direction of a crustal magnetic field patch in Mars's southern hemisphere. See, Mars doesn't have a global magnetic field like Earth. It lost that roughly 3.8 billion years ago when its core cooled and the dynamo shut down. But it has these remnants, localized patches of magnetism baked into the crust from when the field was still alive. And whistler signals can travel along those field lines just like they travel along Earth's magnetosphere, different planet, different physics, same eerie result. Now here's what makes this even more wild. MAVEN analyzed over 108,000 data snapshots from the Martian ionosphere and found exactly one whistler, one, which either means Martian lightning is incredibly rare or detecting it from orbit is nearly impossible. Probably both, but we don't just have indirect evidence. Perseverance has been listening. Number 8. Electric sparks are crackling inside Martian dust devils. Perseverance carries a microphone, and that microphone has picked up something that no one expected to hear on another planet. Popping. Crackling. The unmistakable sound of electrical discharge, happening inside dust devils as they pass directly over the rover. Published in Nature in November 2025, the data shows 55 separate electrical events recorded over the course of the mission. 16 of them happened when dust devils rolled right over Perseverance. Here's what's happening. As the dust tornado spins, billions of tiny particles slam into each other. Each collision transfers electrons. Fine grains go negative, coarser grains go positive, charge separates. The electric field builds and eventually it breaks. Tiny lightning bolts sparking inside a spinning column of Martian dust. And these aren't just curiosities. The sparks carry enough energy to trigger real chemistry. They generate chlorates and perchlorates, highly reactive oxidizing compounds from the chlorine-bearing minerals in the dust, and those oxidizers do something significant. They destroy methane. For years, scientists have been puzzled by methane on Mars. Curiosity detects it, then it vanishes, then it comes back. Some people thought the fluctuations might be a sign of microbial life exhaling beneath the surface, but dust devil sparks offer a much cleaner explanation. Every Martian summer, when dust devils are most active, the electrical discharges churn out oxidizers that eat methane alive. The methane doesn't disappear because something stopped producing it. It disappears because something is destroying it. Electric tornadoes roaming the surface of Mars, generating their own chemistry, oxidizing compounds in their path. If you ever needed proof that Mars is not a quiet, boring rock, this is it. The weather itself is running chemical reactions that reshape the atmosphere in real time, and if you put any kind of electronic equipment in the path of one of these things, the static discharge would almost certainly fry it. Future Mars astronauts aren't just going to have to worry about radiation and thin air. They're going to have to dodge electric dust storms that smell like burning metal and corrode everything they touch. And if you think electric tornadoes chemically reshaping a planet's atmosphere is the strangest thing on this list, you'd be wrong. Because the last discovery on this list suggests something about Mars that nobody saw coming. Number 9. Mars is speeding up, and we finally know why. Over the last decade, researchers measuring Mars's rotation noticed something impossible to ignore. The planet is spinning faster, not by a lot, about 70 microseconds per year, but consistently. Every year, the Martian day is getting shorter. To figure out why, scientists went back to data from the InSight lander, which operated from 2018 to 2022. They combined seismic measurements with decades of Doppler tracking data from Viking, Curiosity, and Perseverance, and built a model of Mars's interior. And what they found was a massive plume of hot, low-density rock rising from deep within the planet, directly beneath the Tharsis region, the volcanic plateau that holds Olympus Mons, the tallest volcano in the solar system. Think of it like a figure skater pulling their arms in. The mass of the planet is redistributing, less dense material moves toward the surface, the moment of inertia drops. And because angular momentum has to be conserved, the spin rate increases. Mars literally pulls itself tighter and spins faster, and that changes everything. Because it means Mars is not geologically dead. For decades, the assumption was that Mars cooled off billions of years ago, that its interior solidified, that the volcanoes went extinct and the planet became a frozen corpse orbiting the sun with nothing left to give. But this discovery says otherwise. There's still enough internal heat to drive mantle convection, to push rock upward through the mantle, to physically alter the rotation of an entire planet. The Tharsis region sits on top of this plume. Olympus Mons, the tallest volcano in the solar system, 22 kilometers high, sits directly above it. And if the plume is still active, that means hydrothermal systems might exist beneath the surface right now. Warm pockets, liquid water, chemical energy, the exact conditions that life needs to survive, not 3 billion years ago, now. And millions of years from now, if that plume keeps rising, Mars might wake up again. New volcanoes, new outgassing, maybe even a thicker atmosphere. The planet that everyone wrote off as dead might just be sleeping. Mars went from having tropical rainstorms in an ocean the size of the Arctic to a planet where lightning crackles inside dust tornadoes, and the ground itself is speeding up beneath your feet. It lost almost all of its water, most of its atmosphere, and its global magnetic field. And yet it still has organic molecules that no one can explain, electrical storms that rewrite its own chemistry, and a molten interior that refuses to quit. Every one of these discoveries happened while the world was watching Artemis. While cameras pointed at the moon, 2 robots on Mars were rewriting the story of the solar system, one rock sample, one radar pulse, one microphone recording at a time. We didn't lose Mars. We just stopped paying attention. Subscribe if you want to keep up with what this planet does next, and check out this video right here. If you liked what you saw in this one, I'll see you there.